Hi students, today we will be looking into Ohm's law and how to deduce an expression for Ohm's law. And this is coming in your chapter 3 current electricity of your class 12 physics. And okay, so let us start. The Ohm's law statement which you're going to learn here now is very different from what you learned in class 10. Here in class 12, Ohm's law states that the current I flowing through a conductor is directly proportional to the potential difference V across the ends of the conductor provided physical conditions of the conductor such as temperature, mechanical strain, etc. are kept constant. That is, see, I will once again read the statement. Ohm's law states that the current I flowing through a conductor is directly proportional to the potential difference V across the ends of the conductor, provided physical conditions such as temperature. Physical conditions of the conductor such as temperature, mechanical strain, etc. are kept constant. So I is directly proportional to V, or we can write V is directly proportional to I. So V is equal to I into R. V by I is equal to R, which is a constant. And here R is the resistance of the conductor. R is the resistance of the conductor. So Ohm's law states that the current I flowing through a conductor is directly proportional to the potential difference V across the ends of the conductor, provided physical conditions of the conductor such as temperature, mechanical strain, etc. are kept constant. That is, I is directly proportional to V, or V is directly proportional to I. So we can write V equals IR. So now we got V by I equals R, where R is the resistance of the conductor and it is a constant. Now let us see how we can deduce an expression for Ohm's law, deduction of Ohm's law. So we know that I is equal to any VD. I equals any VD, and we know that drift velocity is by M, right? Therefore, we can write I equals ANE. In place of VD, I'll substitute this. So, E by n, relaxation time. Now this is going to be n e square to relaxation time by m into e. And this e is the electric field. E is equal to V by L. L is the length of the conductor, so therefore I is equal to like this we can write. And from here what I'm going to do is this V I'm going to bring it here. Down I'll bring. So V by I, no, not that, like that. What I will do is I will take the reciprocal. Everything I am going to take the reciprocal. So before taking the reciprocal, as I said earlier, this V I'm going to bring it over here. So I by V is ANE square ml, okay, like this. Now I'm going to take the reciprocal. So V by I is ml by this. And this is equal to R, which is a constant. We can write this is Ohm's law. This is how you deduce an expression for your class 12 Ohm's law. R is equal to this. So if you're given with all of these, you can find any one of them. Okay. So first we have I equals any VD. And VD here, VD is the drift velocity. VD is the drift velocity, and here this is the relaxation time. I'll write it in a box here. This is the relaxation time. VD is the drift velocity. Then E is the charge on each electron. Now E is the electric field. Then what is left? E, V, D. Yeah. And M is the mass of the electron. Okay. So this is how it is written, how you deduce an expression for Ohm's law. Okay. And here the R is the resistance and it is a constant. This is Ohm's law. So when you write it for finding the if they ask you to derive, this is what you have to write, and you can add a V have here. We have I equals any VD and VD equals E into capital E top M, and here this is the relaxation time. This is the drift velocity, charge on each electron. This is the electric field. This is the mass of the electron. Then I equals any VD, right? So in place of this VD, we'll substitute this. We'll get any square torque by M, relaxation time by M equals VL. This is the length. Length of the conductor is that. Okay. So this is how you write an expression for Ohm's law. R equals V by R is equal to V by I, which is equal to ml by Annie square torque. This is the Ohm's law. And the statement is that the current I flowing through a conductor is directly proportional to the potential difference V across the ends of the conductor, provided physical conditions of the conductor such as temperature, mechanical strain, etc. are constant. Okay, this is how we do. Hope you understood. Thank you.